Okay, probability. First subheading, set notation and Venn diagram. Before we start, there are three things we need to know. A sample space is the set of all possible outcomes in an event. An outcome is a possible result. A Venn diagram is a diagram to show the relationship between two or more sets. Normally you use circles for that. Alright, so let's have a look at the first question. Two coins are tossed. Show the sample space for this event by making a list, a table, and a tree diagram. Okay, so let's have a look at this. So we've got two coins. So I'm going to think about this. Capital H for head. There's only two outcomes, one coin, isn't it? T, capital T for tail. So I'm going to do first, I'm going to do the list. So that'll be, we might have a head, and a head, tail, and tail, head, and tail, tail. Okay, so that's all the possible outcomes. And the table, let's have a look at the table. So I'm gonna draw roughly about this. Okay, so I'm gonna go like that. Let's see if I can do this. Okay, well that looks all right to me. Head, tail, tail. So that will be head, head, tail, tail, head, and tail, tail. So I've got that. Okay, so they've got four outcomes. And then tree diagram. Okay, so that's, I think, a more familiar one, probably. Head, tail. So that's the first coin. We got two of them, so that's the second part. And then what we do here, head, head, and the head, tail, tail, head, and then tail, tail. Okay, so therefore I could say the sample space is, now when you write a sample space, is one of those curly brackets, head, 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 tail, tail, head, tail, tail. Okay, and I'm going to add one more. Here we have four different possible outcomes. Okay, so 1, 2, 3, 4 outcomes. All right, so that's done. Now, next question is about union and intersection. So symbol for that, notation for that is union is like a concave up, you know, cup open or cup down, intersection. Now, union is the one, it's going to be like everything, okay, except that we're not going to count the common part. And intersection is common part only, and there's no other parts. All right, so that's what we're going to do. So let's have a look at this, and then we're going to show this one with a Venn diagram. So I'm going to do that with a Venn diagram. Before I do that, A union B, that will be, combine this together, 1, 2, 3, 4, and this one's common parts, so I'm not going to repeat that, so it'll be 5, 6, 7, and that's it. Okay, now how am I going to show this one on a Venn diagram? And normally it's in a rectangle. It'll help if you can see it. Yes. So, and then there's only two sets here, so I'm going to go like that. One will be A, one will be B. And then I'll go, A will be 1, 2, 3, 4, because that's a middle part is where the common part's going. And then 5, 6, 7. So if you think about this, set A is what? 1, 2, 3, 4. Set B is 3, 4, 5, 6, 7. Okay, the union of that is, I'm going to find my highlighter, this part, all of this is reunion. Okay, so that's done. And B, A intersect B. So only one that it's common is 3 and 4. Oops, curly. And then of course Venn diagram. I mean, in this case you don't really need to draw rectangle. Ooh, excuse my not so nice rectangle. A, B, 1, 2, 3, 4, 5, 6, 7. But only I'm going to highlight the middle part because that's the only common part. That's what its intersect is for. Okay, so be careful with that. Excellent. So the next one, let's have a look at the question for Venn diagram. Okay, so there is a question here. 35 students were asked. 25 have older siblings, 18 have younger siblings, and 3 have no siblings at all. Okay, there are 3 questions. How many students have only older siblings? How many students have only younger siblings? How many students have both older and younger siblings? Now, before we get into this, I need to sketch the Venn diagram with this information. All right. So let's have a look at, I'm going to have to sketch rectangle because we're going to use that space here. Okay, so let's see if I can remember this. So I've got 2 parts. I'm going to call it A and B. A is the older sibling, and then B is the younger. So I'm gonna, before I forget, I'm gonna go older and younger. Okay, so let's have a look. I know that's no siblings going to be 3 here, and I've got to think about this carefully. According to the question here, now there's 35 people were surveyed or asked, and all these need to be added up to 35, but it's more than that. So if you add up 25 plus 18 plus 3, you will get 46, but we only surveyed 35. So that means 11 of them is overlapping. Okay, so that means 11 goes to intersection part. Okay, so what they said was 25 have older siblings. So if I put 25 here and then younger siblings here, which is 18, and then I have to take away what's overlapping. Okay, so I'm going to take away 11 here, take away 11 here, and then I will get only the A section, A set, only the B set. So that will give me 14, that will give me 7. So if I add all this, 17 and 11, 7 and 3, I will get perfect 35. So make sure you check that you got 35, because that's what you're supposed to have, because that's only people we asked was only 35 people. Okay, so that's what we got. Now we can answer all these questions for it. So let's have a look. How many students have only older siblings? So that's, we're looking at only the set A. That's only 14 of them. Okay, and the next one, how many students have only younger siblings? 7. Now this question is really asking, they got both older and younger here. So it's like A union B, okay, which is 11. So I'm going to put 11 here. Now, there's no question about the union, but if I had to find the A union B, I will have to do 14 plus 11 plus 7. Not that one, but 7. So what will that be? That will be 32. Or you can do 35, take away 3. That'll be 32. Yeah, because we are only union of A and B. We're not doing the leftovers. Okay, so it'll be 32. All right, well done.